Okay, so in this video, we will talk about exponential growth model. Okay, so what is exponential growth model? It's actually the model is when time increase, what happened to the output? The output is actually increase as well. Okay, it's increasing as well. So then now this is actually is kind of like the idea. So then you will see that the model that we're using is we could have f of t equal to a times b to the t, or f of t equal to a times 1 plus r raised to the power of t, where r is bigger than 0, or even we could use a continuous growth model, right? A times e to the kt. However, to me, throughout the whole sections, I will use the first one, okay? F of t equal to a times b to t to finish the problem. Okay, so let us look at this problem here. A bacteria culture initially contained 2,000 bacteria and double in size every half an hour. Okay. We would like to find the size of the population after 80 minutes. Okay, so now you will see that to this problem, the information that we have is, we know that the population is double in size every half an hour. Okay, so then now when you have the problem, you need to consider that which formula, okay, that we are going to use. Okay, so for example, in this case right here, I would like to use this model right here, f of t equal to a times b to the t. Now the second thing that I would like to do is, what is the unit of terms that I'm going to use now? Okay. Now you will see that most of the students, when they talk about the units of term, they will think of how about years, okay? Because most of the time is we are going to work with years, right? However, to this model right here, to this problem, you will see that it actually is the double inside every half an hour. So this one right here is only work with hours, right? So some of you actually consider that, how about if I use hours to be a units then? However, you will see that what they're looking for, they're looking for after 80 minutes. So therefore, again, to me, when you have the unit of time is between hours and minutes, then to me, I always choose minutes. Okay, because one thing about this is, a lot of students actually have an easy way to convert hours to minutes, but you may have a hard time to change it from minutes to hours then, right? Okay, anyway, to this problem, I'm going to work with minutes then. Okay, then let us check it out. What information do I have? So if I want to sketch, then we know that I have initial values is actually 2,000. Okay, and then it's telling me that we double in size every half an hour. So meaning what the function basically is increasing, right? Okay. Then of course this is actually is number of bacteria, and then this is actually is my time right here, right? It's in minutes. Okay. Then based on what we just read, we know that we have my initial value is 2,000 right away. We know that A is equal to 2,000. And then now, what other informations that I could use? Here is one. We are going to double in size every half an hour. So how do we actually convert this into some useful informations? Okay. So in this case, it's meaning that every 30 minutes, I will be able to double the size. Okay. Now, if my initial is 2,000, meaning after 30 minutes, what is my output then? Yeah, it's 4,000, right? So therefore, in this case, you find out that I have another ordered pair that I could actually get it from the statement now. Okay. So then how about if I write this in a function notation? So I have f of 30 is equal to 4,000. Okay. Then now it seems that we go back to the previous earlier section, chapter 4, right? We actually went out, I have some given, then I will be able to find the model now. Okay. So if I want to find the model, Now remember, funding model basically is actually we would like to create functions. Okay, so I know that I have f of t is equal to 2000 e to the power of t. And now what I need to do is I just need to find out what is b now. Okay, then how do we find b? We could actually use this f of 30 equal to 4000 to help us to find d. How to find b? I'm sorry. So if I want to find b, then in this case I could have f of 30 is 2000 e to the power of 30 equal to 4000, right? So we have this. And then now, of course, we could have b to the power of 30 is 4000 divided by 2000, okay? Then now we could have this is equal to 1/2. Oh, actually, my bad, is 2, right? Then if I want to solve for b, then we could take the 30 width, or now to me, I'd like to raise to the power of 130, okay? The reason is, again, think about this. If I raise to the power of 130, then 30 and 30 cancel out, then you have e, right? Okay. Now, one thing about this is, this number is the exact value. And of course, you could actually use your calculator to round this number up. So you could write it as 1.0233733892. Okay. Now, to me, I prefer this exact value. Okay. Of course, some of the students try to round it. Okay. Now, I will show you what is the problem if you round it too much. Okay, or too early. Then let's see what happened to the result. Okay. But anyway, now I have these two models now. Okay. So let me write that. So I will have, again, I have f of t equal to 2000 2 raised to the power of 130 and then raised to the power of t. This is b, right? Or I could rewrite this into 2000 2 raised to the power of t over 30. Okay, I simplify. Of course, I could also use f of t equal to 2000 1.02337 raised to the power of t. Okay. Now, to me, the rule of thumb is, if you want to round, then I would like you to round it 4 significant figures. Now, again, it's not 4 decimal places. It's 4 significant figures. Okay, so meaning what? You can, after decimal, counting 4 without 0. Okay, counting 4 digits right there. Okay, something like this. Okay, so let me show you. Then after we have the model, then of course we could actually plug it in to find the solution then, right? So then when t equal to 80 minutes, then of course I will have f of 80 is 2000 times 2 raised to the power of 80 over 30. Okay. Then let's just try to use a calculator. Okay. And also remember these b values, okay? Okay, so then let us do this. So I will have 2000 times 2 raised to the power of 80 over 30. Okay. Now you will see that the answer that I have is 12,699. Again, of course, we don't want to have 0.2 or 0.5, something like this, because we talk about bacteria. Okay, so we round it to 12,699. Okay. Now, what if I'm using 4 significant figures? 1.02337, and then raised to the power of 80, right? Now you will see that the result that we have is not a lot of rounding. So we only have like 4 bacteria different, right? This is not a lot. But look at this. How about if you round it to 0.023? Some of you feel that, how about if I round it to 3 decimal places? Okay, raise the power of 80. Do you see the difference? It actually is a lot already. That means the difference is 300 of 60 difference. Wow. Some of you actually, wow, maybe feel that, how about 2 decimal places? 1.02 raised to the power of 80. Okay. You will see that this is the idea why we don't want to, that means round it up too soon, then you will end up with the rounding error. Okay, so if you type it in 9,751 to your calculator, then you will see that your answer is not correct at all. Okay, so therefore, again, be careful about the rounding error then. Okay. So again, to me, I would like to use the exact, this one, right? The exact value. Unless the problem actually asks you, okay, I need to round, okay. Okay, so then this is actually is the number 1, okay. Now the next terminology that I would like to introduce is the doubling time. Sometimes the problem just asks you, oh, I would like to find the doubling time. So what does this mean? The doubling time of the going continuity is the time is take for the quantity to double. Okay. So now based on this statement right here, what does this mean? Is actually is tell you that if I want to find the doubling time, I need to set up the a of t equal to 2t, or 2a, okay. So I want to know how long it will take the quantity to double, okay. So therefore I will set up a times b to the t equal to 2a. And if you simplify, if you divide both sides by a, then you will see that basically we have b to the t equal to 2 then, right? Then now from there, then we could take the natural log to both sides of the equations and then solve for t then, okay? So this is the idea about the doubling time. Okay, so then maybe let us do this problem now. I would like to find the time to require for an investment to double in values if the invest in an account paying 4% compounded monthly, right? Okay, so if you remember, if I need to work with a compounded monthly, then of course the formula that I'm using, it will be a of t equal to p times 1 plus r over k raised to the power of kt, right? This formula right here. Okay. Now, of course, if we have compounded continuously, then of course we will use a of t equal to p times e to the rt, right? Compound continuously. But anyway, to this problem is this one right here. Then what do we know? Okay, so of course we know that the interest rate is 4%, which is 0.04. And then we also know that the k is equal to 12. Okay. However, the problem didn't tell us the principal. Oh, my bad. We are using a, right? Of course, the problem didn't ask, that's been given the principal. But again, actually, I don't care about the principal. The reason is we just need to know how long it will double it, right? Okay. So then now, how do we actually, again, first, maybe let me set it up, the problem. So I have a of t equal to a times 1 plus 0.04 divided by 12 raised to the power of 12t, right? We have this. Okay, then now I would like to find the doubling time now. Okay, how long it take to double the investment, right? Then I will set a times 1 plus 0.04 over 12 raised to the power of 12t equal to 2a. Okay. Now, one thing about this is, do you see that I didn't round this number? Okay, I would like to use the whole thing. At the end, I just use my calculator to help me to find the t then. And now I divide both sides by a. Okay. Then I will have 1 plus 0.04 divided by 12 raised to the power of 12t equal to 2 now. Okay. And of course, right now we have an unknown power, right? So we will take the natural log. Okay. Then, of course, we could bring the power down. Or t is equal to natural log of 2 over 12 times natural log of 1 plus 0.04 divided by 12. Okay. And now we just use a calculator to find this answer now. Okay. Okay, then let's show you how we do this on a calculator. Okay. Okay, now to this one right here, what we need is we have natural log 2, close it, divide this. Now remember, we need to put a parenthesis, right? 12 times natural log of 1 plus 0.04 divided by 12. Okay, we close this, close it again. And then now you will see that the answer is 12.36, okay? We just wanted two decimal places. So it will be 12 times 36 here. Okay, so it will take, oh man, my bad. It should be 17, right? Oh, I could not read that. Okay, so it will take 17.36 years to actually double the investment. So meaning if you put $1, you will wait 17 years to get $2, right? If you put 1,000 and then 17 years later, you have 2,000 and so on and so forth. Okay, so now then let us look at another example. Now this example right here is that the count of bacteria in a culture was 600 after 20 minutes and 2,000 after 35 minutes. Okay, so to this problem, how do we actually work on this problem right here? Okay, now anyway, let's go for the first step is I'm going to use the model is f of t is ab to the t, okay? And then t is in minutes, okay? Okay. And then now what information do I know? I know that to this one right here, the model is increasing. Okay. And one thing about this is at 20 minutes, my bacteria is 600. And then another is when T is 35, my bacteria is 2,000. Okay. So meaning right now I actually have 2 ordered pair. Okay. Wow. If you go back to chapters 4.1, then we have learned that if we have 2 points, how do we actually find the model then, right? So this is right now, this is what we are going to do now. So again, if you should pause the video and then try the problem, okay? So then I set it up, f of 20 is equal to ab to the 20 equal to 600. Then f of 35 is ab to the 35 equal to 2,000. Okay. Now remember, to this type of problem, what we want to do is we want to solve for a, and then use substitution to find b, and then after we find b, then we find a, right? Okay. and I call this is E1, this is E2. So from E1, we know that is A is equal to 600 over B to the power of 20. Okay. And now we are going to substitute A equal to 600 over B to the 20 in E2 now. Okay. And now I will have 600 over B to the 20 times B to the 35 is equal to 2000. Okay, so we know this. And of course, here we could actually B to the 20 and B to the 35. Then we simplify, it will be B to the 15, 35 minus 20, right? And then now we could actually to divide both sides by 600. Okay. Then of course, we could actually have B is equal to 10 over 3 raised to the power of 115 now. Okay. After we find B, then of course we will be able to find A now, right? So it will be equal to 10 over 3 raised to the power of 115 in E1. So again, this step is we are using B to find A. Then I have A times 10 over 3 raised to the power of 115 raised to the power of 20 is equal to 600. Okay. Then now, of course, we could solve for A is 600 over 10 over 3 raised to the power of 20 over 15. Okay. And now you could use your calculator. You find out that is 120.497931. Okay, now to this problem, then let's see. Well, we would like to find the initial size. So, therefore, in this case right here, we could make the conclusion that the initial size of the bacteria culture, right? Or maybe of the culture is 120. Now you will see that I will not write down as 120.5 because again, bacteria, you could not count it, half of it, right? Okay. So then now it's turned out that how about the model then? So if my initial is actually 120, then what I would like to do is the model that I'm going to do is I will write down is 120, okay? And then 10 over 3 raised to the power 1/15 raised to the power t. And now I'm going to simplify this. And this is actually is my model now. Okay. And after we have the model, then of course we could use the model to help us to finish the B and C, right? Okay. Now again, if you want to round it, remember the rule of thumb to round this 10 over 3 raised to the power 115. Then if you use your calculator, you should get is 1.08357. Again, I round is 4 significant figures. Okay. But again, I prefer this answer right here. Okay, so then now we would like to work with the brewing time, and then we would like to find the population after 170 minutes. Okay, then let's see how do we work out that problem. So of course, the doubling time basically is we have 120 10 over 3 raised to the power of t over 15 equal to 240, right? We double the initial sum. And then we divide both sides by 120. Basically, we know that this is equal to 2. Then the next step is we take the natural log. Then we solve for t. Then of course the t will be 15 times natural log of 2 over natural log of 10 over 3. Okay. And now your answer should be 8.64 minutes then. Okay. Yeah. And the last one is we will find the population after 170 minutes. Okay, so then we could have P of 170 is 120, 10 over 3, 170 over 15, right? And then it will be 101, 190,644. Okay, so then that's it. Okay, so to the next video, I will talk about the decay model now.